Hi, I'm doing Paul McWhorter's Pico W lessons and I'm up to lesson number 105, and Paul wanted us to control neopixels with PIO. Now, whenever someone gets out a calculator and starts punching in numbers and jotting figures down on a bit of paper, I always think there must be a better way of doing it. So I had a look for the data sheet and I found this via Pimoroni, and it's kind of the data sheet for the neopixel thingy, what's it? And it's similar to Paul's, but not exactly the same. And I was only interested in this table here. And it means that if you want to output a 0, it says you need to have it high for 0.4 microseconds and then low for 0.85 microseconds. And equally, if you want to output a 1, you have it high for 0.85 and low for 0.4. And I looked at that and I thought, that's annoying, because to save yourself complicated maths, it'd be so much easier if it was 0.4 and 0.8. Oh no, 0.4 and 0.8 and 0.8 and 0.4. But if you look at that those values, you've got a bit of wriggle space there. So if you take that 0.85 down to 0.4, it's within the allowed variance, that's what you call it, of that number. And so that means you can have it 0.4 and 0.8 and 0.8 and 0.4, and the total the data transfer time, you add the two together, and as opposed to they're saying up there 0.25 plus or minus whatever, it's 0.2, which equally is within the limitations of the plus or minus 600 nanoseconds. So I thought that will work wonderfully. So that means the transfer time is 1.2, which can easily be divided into a 0.4 and a 0.8. You could divide into 12 cycles, but I thought, as they're both even, why not divide it into 6 cycles? 3 cycles would be, it wouldn't work, because as we saw from Paul's lesson, you need to start off with a low and then have the high bit and then with a low at the end, if you see what I mean. So I thought, right, so each cycle wants to be 0.2 microseconds. So I'll show you what I mean here. This is my PIO bit, and here we have 0 needs to be high for 0.4, low for 0.8, and you need to start off low and end up low. So being symmetrical, it can go low, low, high, high, low, low. That works. Here, 1 needs to be high for 0.8 and low for 0.4, and you have to have the lows on the end, so it's low, high, 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 low. That works. Data transfer time, 1.2 microseconds. Yep. Divide that into 6.2 microseconds, and therefore the frequency is 1 divided by 0.2 microseconds is 5 million. That all works wonderfully. Next, you need that to be 6 cycles long. So that's 1, yep, 2, 4, 5, 6. Right, everything is looking good so far. you start off, when you initialize it, you set it to low. So that means that for that first instruction, it's low. So it's low for 1. And what you're doing there is you're reading the first bit from the OSR and putting in X. Then what you're doing is you're moving X to the pins. Now if X was 1, then you're moving in, it will be high, and if X is 0, it will be low. So you can see there, 0, that one there, low, yes, that one there, high. Then whatever, whether it's low there or high, the two middle want to be high. So that is exactly what that's doing. It's setting the pins to high for 2 cycles. Then again, we're doing exactly the same as we did there. We're moving the X to the pins, so if it's for 0, as in there, it will be L, and if it's 1, it will be high. Everything's working so far. And then for 1 cycle, you set it to low. And that is an awful, I'm not really too au fait with side set and everything, but to my mind that is an awful lot easier than the way Paul was doing it. But he's worked, and as he said, you just need it to work. Right, so to test this out, I thought, oh well, in lesson 53 we controlled neopixels, only we used the neopixel library and it all worked fine. And I thought, right, I will just reuse this code, and every time it says neopixel I'll do my own thing. So here, neopixels, right, you set that up, and down here I'm just setting up my colors, and you don't do an awful lot with this neopixel thing. You can fill the whole lot with a color. You can so you've got the fill method on it, and you've got the write method, which obviously writes them, and you've also got the pixels I equals a color. And I didn't know how that worked. What I wanted to do with my program was just to write my own class and do exactly the same thing, only I was using neopixels, PIO, but it wasn't that easy because I looked at this. This is written by Damien P. George, who's an awful lot cleverer than me, and what he's doing is in his class he's using set item and get item, which means you can pass to the class an index and the value. And I tried doing this and I couldn't do it, so it was very disappointing. So I will show you the dummy's way of doing it. So I've taken my initial program from lesson number 53 and I've just changed it a bit. I've taken out the neopixel thing, and there's my state machine bit, and I've just got two functions. One is to fill the color and one is to write the pixels. Then that's just the number of I'm just setting up the number of pins, number of LED, the pin number, the number of LEDs, blah blah blah, setting up the rainbow. They aren't in the right order, but I just did it so it showed better on the display. And then I'm setting up the array of pixels for it, which I'm just filling with 0 because black is 0. And then I've just created another array for the colours, which kind of makes it into this one integer long for the thing, like Paul was showing us, that you take the green, you shift it, you take the red, you don't shift it as far, and you take the blue. And I'm not very good at shifting, so I just multiplied up. Then starting up the state machine. Then this is just all my things from the last time, and at the end, if I press Control C, it I fill it, turn off all of the LEDs, write them, and deactivate the state machine. So I will just see if we can run this. Get rid of that. Get rid camera. Right, there we go. If I give it a bit of shade in. I want to get rid of, I was thinking that was a reflection, it's the lights from behind. Right, I don't know how well this works. We'll just run this and see what happens. Right, in the beginning it's just filling with the colours of the rainbow. Then it's doing the gradual fill, and this is like an array of 20 neopixels, because I couldn't find my strip. And then that's just random fill. Then this is the kind of running rainbow, or whatever you call it, so we'll go 3, and it kind of does a scurrying around and fills it up with 3 of each colour, and then it goes round and round and round, and it says enter to replay. We don't want to do that. Control C. It turns everything off and deactivates the thing. Terrible video, but it wasn't the demonstration that was interesting. It was the fact that I thought of a way of simplifying the maths, but probably everyone else has come up with a solution anyway. So that's my program.